Hello, everyone. My name is Shoaib Khalid. Today, I'm going to present my final machine learning project. So, it is on Bitcoin price prediction with machine learning and LSTM approach. Introduction. In this project, we propose a predictive model using a long short term memory neural network to forecast Bitcoin prices for the next 10 minutes. The model integrates both historical price data and real time market sentiment gathered from news sources to make predictions. The primary goal is to develop a system capable of predicting the price of Bitcoin, assisting traders in decision making. So, the problem definition: Bitcoin price is influenced by multiple factors, including market sentiment. News and social media play an essential role in shaping investor sentiment, which is in turn affects price movements. Historical price price, valuable insights into the trend and patterns that can be exploited for predictions. In this project, the problem is defined as predicting the next minute's Bitcoin price based on the past 10 minutes of data and real time market sentiment contribution. The contribution of this project lies in both development of predictive system using an LSTM model and innovative integration of market sentiment data. The LSTM model, which is widely used for time series prediction, leverages historical Bitcoin price data to make predictions. However, the unique aspect of this project is incorporation of real-time sentiment analysis from Bitcoin-related news headlines, which helps refine the prediction by adding an extra layer of context. Original contribution: LSTM model development. The architecture of LSTM model was built and turned to handle time series data and predict future Bitcoin prices. Market sentiment analysis. We integrated sentiment analysis to improve the model accuracy. This was done by scraping live news headlines and using pre-trained sentiment analysis model. Reused contributions. So sentiment analysis pipeline. The sentiment analysis pipeline used in this project, Distilbert based model, was pre-existing and publicly available via the Transformers library. API data sources. The API used for fetching Bitcoin price data, crypto compare, and news articles, news API were external resources. Creativity. This project's creativity lies in its approach to integrating traditional time series forecasting with real-time sentiment analysis. While LSTMs are standard in time series forecasting, the addition of sentiments data make this approach innovative. Market sentiment, often neglected in traditional models, has the potential to improve prediction accuracy in volatile markets like Bitcoin. The dataset used for this sentiment analysis is novel, as it combines the latest headlines related to Bitcoin, which could be highly relevant to the price movement at any given. So that are coming from that API crypto compare. Complexity. The complexity of this project is beyond the simple use of existing tool. The challenges tackled include data collection, real-time data fetching from API from both Bitcoin prices and market sentiment required integration of multiple external services, modeling, building and tuning an LSTM model for predicting Bitcoin prices based on sequential data is non-trivial task. The model had to be trained over multiple epochs to ensure accurate predictions. Integration, combining historical price data with sentiment analysis for news and articles required careful handling and synchronization of different data sources. The project goes beyond using basic constructs or libraries by implementing a novel hybrid model that uses both technical indicators, historical price, and fundamental indicators, sentiment analysis. Ethics. Some potential ethical considerations include bias in sentiment analysis. Sentiment models can be biased, especially when trained on data that may not represent diverse opinions or perspectives. If the sentiment analysis model produces biased results, it could lead to skewed predictions impacting traders' decision. Market manipulation. If this model were to be used on a larger scale, there is a risk that certain actors could manipulate market sentiment and influence predictions, potentially cause market disruption. Transparency. The working of deep learning models, including LSTM, are often not fully transparent, which could raise concerns for users relying on predictions for decision making. Having transparency about models' limitation and its data sources is important. Methodology. Data collection and processing. The data used in this project consists of two main components: historical Bitcoin price data. We fetch Bitcoin price data for past 60 minutes for the crypto compare API. Sentiment data. We scrapes news articles related to Bitcoin from News API, performing sentiment analysis on the headlines. The collected data is then processed. Normalization. The Bitcoin price data is normalized using the mix-max scaler to scale the data between 0 and 1, which is common practice in machine learning. Sentiment analysis. Using the pre-trained Distilbert sentiment model, we classify the market sentiment as either positive, negative, or neutral based on the headlines of the most recent Bitcoin-related news. Model architecture. The LSTM model architecture consists of input layer, 10 time steps of Bitcoin prices, LSTM layer, 50 hidden units, and two layers. Output layer, a single value representing the predicted Bitcoin for the next minute. Training evaluation. The model is trained on the historical price data using the mean square error loss function. The optimizer uses ADAM, and the training runs for 500 epochs to ensure convergence. Prediction. After training, the model predicts the next minute Bitcoin price based on the last 10 minutes of price data. The model is then used to predict price for the next 10 minutes. That is shown in this graph. The predicted Bitcoin graph shows an initial rise peaking around minute two, followed by a steady decline until minute eight. Whilst, with a slight recovery at the end, this trends could indicate market momentum corrections or trading volume shifts. The traders might sell at the peak and buy near the dip. But real time factors must be considered to improve accuracy. Further model validation and refinement against actual prices are needed. Results, model accuracy. So this graph, loss curve, this graph will show how the training loss decreases over time as the model learns. It will be useful for understanding how the model performs improved during training. Predicted versus actual price plot. This graph will compare the actual Bitcoin prices against the predicted price during the forecast, shows the model's accuracy visually. Sentiment impact. So sentiment data also affects predictions. For instance, the sentiment for news headlines may correlate with large price movement. Incorporating this sentiment can improve the model's ability to predict price jumps. This is an example sentiment over time plot. My code does not show that. Conclusion. This project demonstrates the power of machine learning is predicting Bitcoin prices using an LSTM model combines with real-time sentiments analysis. While the model shows promise, there is always room for improvement, especially in expanding the dataset and improving the sentiment analysis pipeline. By including sentiment data, this model may have a comparative edge in predicting Bitcoin prices, especially when combined with other financial indicators. Future improvements could include incorporating a broader set of features, example, trading volume, technical indicators, using a larger dataset for training, refining the sentiment analysis model to reduce bias. Now I will show you the demo of my code. So as you can see, I have already run this code and I got this output, the epochs, the predicted Bitcoin price for next 10 minutes, training loss curve, and the predicted versus actual Bitcoin prices. Current Bitcoin price, market sentiment is minus 0.396, which is negative. Sentiment score is negative. The predicted next minute price is 8711.281. So it's still going high in the next minute. Uh, that's it. Thanks a lot.